Okay, students, so we'll move on to the next topic, that is divisible by k problem. Okay, so in previous session, we discussed total 14 different problems over pattern recognition. Means in your question, there will be so in previous session, we were discussing about pattern recognition problem, right? Okay. So in the question, they used to provide some set of pattern over there, like it should begin with A, it should end with A, or how many number of A should be available, how many number of B should be available, or how many number of zeros should be available. Okay. So even number of A's, odd number of B's, okay, such kind of pattern they used to mention in a question. Okay. But now from here, we are following a property of divisible by k problem. Okay, so here they used to mention like divisible by 5, 6, 7. Okay, such kind of like we need to divide the number which has mentioned in your question exactly. Fine, so that kind we are calling it as divisible by k problem exactly. So we'll go through this, what exactly divisible by k problems are. So in this section, let us discuss a method of constructing DFA that divides a number by k. Okay, so in your question they had mentioned that the value of k in your question exactly. Okay, using that value of k, we need to start dividing the number. Okay, from that division, we need to extract some result. Okay, so using that, we need to using those values, we need to apply it for this particular formula. Okay, remember this is very important formula if you want to solve the divisible by k problem exactly. Okay, for this type of problem, because the transition can be obtained using the following relation. Okay, so previously what we used to do, we used to check like if it is changing from q0 to q1 on receiving a and b. Okay, like we are manually we are calculating, right? But here we are calculating based on this transition function formula exactly. Okay, observe it carefully. Delta of qi comma a will be equal to qj, means state qi will change its state from qi to qj on receiving a. But how to decide the j value? Okay, where j will be is equal to r into I plus d. Okay, r into I plus d mod k. K will be specified in your question. Fine. R we can easily identify like what is the radix. Okay, we call it R stand for radix. For binary it will be 2. Remember. Okay, so radix will be known in prior itself. Okay, then I stand for the remainder. Okay, remember this. I stand for remainder, and D represents the digit. Okay, for binary it will be 0 and 1. Okay, for the normal number 0 to 9 it will be. Okay, so we won't get any kind of like a comma b comma c, such kind of input alphabet we don't get over here. We will be getting either a number or else a binary representation we used to get. Clear? Okay, so k will be specified in your question. Okay, d we can easily identify based on the alphabet what you got. Okay, then r will be the by default known, like for binary r will be equal to 2, radix we call it as. Okay, then what does this I stand for? See here, I is the remainder obtained after dividing by k. Fine. In the future, in next problem, okay, when we are starting the first problem, okay, we are having k value 5. Okay, 0 modulo 5 we call it as. Means whenever we divide a number, we should get a 0. Okay, such kind of number should be accepted by the DFA. Rest of all should be rejected over there. Yeah. In such cases, okay, the possible remainder, whatever we are getting using that k value is what? 0, 1, 2, 3, 4. Is it? Okay. Means if you are dividing any number with value 5, the possible remainder we are getting is what? Either 0, 1, 2, 3, or 4 exactly. Right? Okay. So such kind of how many reminders we can get if you are dividing a number using k, that we need to find. Okay. So that will be your I exactly. That will be I exactly. Clear? Fine. So using this formula, we are finding if you are in state Q0, so what will be the next state on receiving one particular input alphabet? Okay, so here we are representing it as A. Actually, we are using 0 and 1 exactly. Fine. For your understanding sake, we are writing it as A exactly. Okay. So here the explanation regarding each and every value we are having. R is the radix of input. Okay. For binary, R will be equal to 2. Okay. I is the remainder obtained after dividing by k. Okay. Then D represent digits. For binary, D will be equal to 0, 1. Okay. K is the divisor. Okay. Now we'll see what are the steps involved in over here. The steps to be followed to find the DFA or else finite automata using this type of problem is shown below. The first one, identify the radix. R should be identified. Input alphabet and the divisor or the divider k exactly. Fine. So these are all we can identify based on the question. Okay, using the information available in the question, we can find what is K. We can find like the input alphabet, that is D exactly. Then we can find the radix exactly. Okay, three things we already know: 1, 2, 3 over. Then I we need to find. Then later in the second step, compute the possible reminders. Okay, compute the possible reminders means how many reminder we can generate. Okay, if you are dividing any number with that particular divider K. Okay, so that we need to check. So compute the possible reminder. So these reminders represent the uh, states of DFA. Okay, so the possible reminders, whatever we are getting over here, right? Okay, so that should be the states. Okay, what we are going to face in the for the DFA design. Fine. So these are the positive, the reminder, whatever we are going to get, that will be the states we are going to get in our DFA exactly. Remember. Okay. So when we solve one problem, you can identify it properly. Then find the transition using delta of Qi comma A. See here I what we have and here I what you are having, both are same. Clear? Both are same. If I is equal to 0, both the condition, we need to substitute I is equal to 0 over here. Don't get confused. Okay. So find the transition using delta of Qi comma A will be equal to Qj, where J will be equal to R into I plus D mod K exactly. Then construct the DFA using the transition obtained in step number 3. So whatever the transition table, what we are designing using this particular formula. Okay. So using that, we need to design the transition diagram for this particular DFA. Yeah. So this is what some basic information about this particular uh, divisible by K problem exactly. Okay. Please remember the formula. Rest of all are very simple kind. Okay. So now we'll go for the first problem. Observe it carefully. Consider DFA which accepts strings of zeros and one. Observe it, zeros and one, where the value of each string is represented as a binary number. Okay, so whatever the number we are going to face, okay, that will be represented in case of a binary exactly. Okay, means the digits D will be what? 0, 1. Okay, from this we can easily identify that digits are 0, 1. The alphabet, whatever we are using, right, that will be the digits over here. Okay, for binary, only two numbers we are having, 0 and 1. So D will be equal to 0, 1. Okay, fine. Then later, only the string representing 0 modulo 5 should be accepted. 0 modulo 5 means what? A number, okay, if you are dividing it by 5, if the remainder is equal to 0, okay, only that number should be accepted by the DFA. Okay, means the number which is divisible by 5, okay, should be accepted. Rest of all should be rejected. Remember this condition. Okay, so here, what they are representing, see, 0 modulo 5. Okay, 0 modulo 5 means K value is 5 over here. We need to divide it by what value? 5 exactly. So K value become 5. Okay, so now we got two things. One is what the D value and one is what the K value. Okay, should be accepted. Then, for example, like continuous 4, 0, value 0, then 5, then 8 plus, sorry, here 5 it is, then 10 exactly, then 15 exactly. 0, 5, 10, 15, 20, 25, 30, such kind of value should be accepted over there. Okay, rest of all should be rejected. Like that we need to discuss or we need to design our DFA. Yeah, very simple. Okay, we need to substitute the value for the formula. Okay, we need to design one table. That's it. Using the table, we need to draw the DFA over there. Clear? Okay, fine. So now the DFA can be obtained as shown below. Fine. Identify the radix, input alphabet, and the divisor K. Okay, in this case, R will be equal to 2. Okay, from the basic discussion itself, we found that for the binary number, radix will be equal to 2. Okay, so in the next problem, we'll see that for the normal number, what will be the radix? Okay, so R will be equal to 2. Then D, the input alphabet, the digits, what we are calling 0, 1 we are having, right? Okay, here 0, 1 we are having. So here D will be equal to 0, 1. Okay, K will be equal to what? 5 exactly. So this is what the first step to identify R, D, K. Okay, then later, step number 2, compute the possible reminders. Okay, we need to find what are the possible reminders we may face. Okay, if you are dividing any number with 5 exactly. So if you are dividing any number with 5, the possible reminders will be either 0, 1, 2, 3, 4. Is it right? 13 divided by 5. What is the remainder? 3 exactly. 14 divided by 5. What is the remainder? 4 exactly. Right? 15 divided by 5. What is the remainder? 0 exactly. 16 divided by 5. What is the remainder? 1 exactly. Right? Then 17 divided by 5. Remainder will be what? 2 exactly. So if you are dividing any number with 5, the possible remainder, whatever we can find or we can face is what? Either 0, 1, 2, 3, 4. Okay. So for this DFA, the states will be 0, 1, 2, 3, 4 exactly. It means Q0, Q1, Q2, Q3, Q4 exactly. Okay, so total 4 different states we are going to find in this particular DFA. Clear? Then we'll go for substituting these values for our formula. So compute transition. The transition can be computed using the following relation. That is delta of qi comma a will be equal to qj, where j is equal to r into I plus d mod k. Okay, with r is equal to 2, k is equal to 5. Okay, so now we'll see how we can draw or how we can utilize this particular formula over here. Okay, so here, so j will be equal to 2. 2 means radix r is fixed exactly, r won't change, remember. Okay, and k value is also not changing over here. Okay, k value and r value will be fixed. Because of that, we are writing it by default. Okay, like uh, the formula for j exactly. J will be equal to 2 into, what is this value? I exactly. 2 into I. This will vary. Remember that I value will obviously will vary. Okay, according to the condition, because 0 to 4 we are having, right? So I value will change exactly. Then what about D value? Okay, D value also change, because sometimes D value will be equal to 0, sometimes D value will be equal to 1. Because D is equal to 0, 1, right? We need to try it for once it for 0 and another time it should be for 1 exactly. So I value and D value, we are keeping it as I and D itself. Rest of all constant, whatever we are in 2 and 5, that we are directly substituting over here. Okay, or else, okay, we can write like this also. Fine, 2 into I plus D mod 5 will be equal to J exactly. Fine, okay. We'll see now how it will be. So this is what the table, fine, this is what the table of the transition. So the first column, remember, it should be reminder. I value it is. First column should be I value exactly. Okay. Second column should be digit D. What are the possible digits? 0 and 1. Once we need to try I value for 0. Second, we need to find like I value for 1 exactly. Okay. D value will change. 0 and 1 we are having. I value will be 0 for this particular row exactly. These two rows. Okay. Or else I value will be fixed for both the values of D. Okay. Next value. Again, we need to check. Next value, again, we need to check. Like that it will be. Okay. So now, observe, I will be equal to 0, first value. D value it is. This is what the formula, what we are substituting. And this is what the result, what we are getting. Okay. The result, we are writing in this particular form. What is this? Delta of qi comma d will be equal to qj. See here, D stand for the input alphabet, right? So in the place of D, sometimes we get 0, sometimes we get 1. Okay. Means first we need to try with 0, second we need to try with 1. Clear? That case we are. Okay. So now I value, we need to write it over here. By default, you can write it over here. I will be equal to 0, I will be equal to 1, I will be equal to 2, I will be equal to 3 and 4. Okay. So these are the possible reminders. Okay. So in our formula also, we need to use the I value, what you are using over here from the first column. Okay, D value 0 and 1. So now we'll deal with the first formula. Okay, 2 into I plus D mod K. See here, R into I plus D mod K. Okay, R value 2, I value, what you have? 0 you are having, plus D value. What is the D value? 0 over here. 2 into 0 plus 0, 0 exactly. 0 mod 5 will be 0, right? 0 mod 5 will be 0. So delta of formula we are substituting, delta of Q, what is the value of I? 0 exactly. 0, see, don't get confused with value of I and D. Don't get confused with value of I and D, because I observed, okay, during valuation of your like paper, okay, so like your seniors always do the mistake, like they used to get confused with the value of D with value of I. Okay, so for this, they are writing 0. For this, they are writing 1 over here. That is totally wrong. Remember, this is the value of I. Okay, this is the place of I. Or else don't compare this, or don't consider this I value. Directly come for the remainder and just consider the value of I, please. Okay, so delta of Qi comma 0 will be equal to Q naught. Okay, why it is Q naught? Why it is Q naught? Here, 0 we are writing. From where? Actually, this is a place of Qj. Okay, where we have a J value, see, these are the J values. Means Q naught on consuming 0, okay, it will be going for 0 exactly. What does J stand for? 0 exactly. Okay, where you are having Q 0. Okay, Qj means Q0. Okay, now we are substituting I value as 0 and J value as 0 exactly. So this will be a self flow. Like that, we need to try it for D value is equal to 1. So 2 into 0, this is I value, plus 1 mod 5. So 2 into 0 plus 1, 0 plus 1 exactly. So 1 will be the result. So 1 mod 5 will be 1 exactly. So delta of Q naught comma 1, 1 is what the input alphabet over here. Delta of Q naught comma 1 will be equal to what? Q1 exactly, because you are getting 1 over here. Like this, we need to try it for all the possible values of I and the possible values of D exactly. So according to this 0, 1, 2, 3, 4, 0, 1, 2, 3, 4, we are getting. Don't mug up this values. Okay, so this should be generated using this particular formula. Remember, okay, using this formula, it should be generated. Remember this. Clear? Okay, so you won't get the same proper sequence like 0, 1, 2, 3, 4, 0, 1, 2, 3, 4. You may get different also. For this question, we are getting this sequence. Clear? So this is what the transition function, what we can get. Okay, so now what we need to do, we need to represent the DFA skeleton as well as the machine representation. Okay, so now we'll go for the machine representation. So Q will be equal to Q0, Q1, Q2, Q3, Q4. Then sigma will be equal to, see, as I mentioned, 0, 1 digits. Whatever we are having, that we are considering it as the alphabet. Then Q0 we have is the start state. Final state. Now, observe it carefully. Final state, which should be considered as the final state. Huh? How I am deciding like Q0 will be the final state? Based on what grounds we are deciding like Q0 is the final state? Till now we did discuss like how to decide the final state. Start state, obviously Q0 is. Remember, what we are trying to make accept over here, 0 modulo 5 over here. Okay, so remainder 0, right? Okay, so what you are expecting, 0 you are expecting. Remainder should be 0. Okay, so which state, okay, we are representing it with 0 should be called as a final state. Okay, if you are trying to accept the DFA, okay, which is yielding the remainder 1, then Q1 will be the final state. If the remainder you are expecting is 2, then Q2 will be the final state. But what is the remainder you are expecting over here? 0 you are expecting. Because of that, Q0 should be made as final state. Okay, so from the previous slide, okay, we are retrieving this transition diagram. Like Q0 on receiving 0, it will go for Q0 itself. Q0 on receiving 1, Q1 itself. So we just go through this. Okay, we are getting the same, like what we are generating from the table, same thing we are representing in the format of a transition table. So just observe this. Based on this, we are drawing like this. Okay, it is not compulsory like your DFA must be in this format itself. Okay, because we cannot remember or we cannot expect the same question in your exam. Okay, it is up to you, but the transition should be proper. Remember, okay, you can write it in a single line like Q0, Q1, Q2, Q3, Q4. Okay, you can write it like that, no problem. Okay, and if you want to design some other gesture also, that is also possible. Okay, so see here Q0 on receiving 0 self loop you are having. Q0 on receiving 1, it will go for Q1. Okay, then Q1 on receiving 0, it will go for Q2. On receiving 1, it will go for Q3 exactly, like that it is. Now, we'll consider one example, like if you are receiving a value of 10, okay, whether this DFA is able to accept or not. Okay, and later we will discuss about one more variety, that is what the 12. Okay, if you are providing an input called as a 12, whether it is able to accept or reject. Okay, so now on one we are receiving the first one, so Q0 will change to Q1. Okay, later what we have 0 we are having. Okay, so after receiving 0, it will come to Q2 exactly, right? Then when it is receiving the next value, that is 1 in the Q2, it will be going to Q0 exactly. Okay, so now inside the Q0, if you are receiving 0, then we are having a self loop, then finally it will be accepted over there. Then we'll compare this with another value, 1100. See, double 1, right? First one, second one. Later one more 1 we are having, right? Okay, so double 1. Okay, first one, second one. Later what we have 0 we are having. So you will be going for Q1 exactly. Later you are having 0. So you will be going for Q2 exactly. So you are at Q2 when you are reaching the end of this string. Okay, obviously it will be rejected. Okay, so now, so this is what we can say, like this is what the DFA, what we can design it for this particular question. Yeah, if you are following a proper formula, then easily we can get a result for this. Okay, remember this. Okay, fine. And over here, observe that for modulo 5, number of states of DFA will be 5 exactly. Okay, for modulo 5, the number of states will be 5. Remember this. Okay, in general, for modulo K, the number of states of DFA will be K exactly. Okay, how many number of states, you may be having confusion, like how many number of states we may receive for the DFA over there. Okay, whatever the K value we are having, those many number of states you are going to get. See here 5, modulo 5 it is, K value was 5. So total number of states, how much you are getting? 5 you are getting. Okay. So this was a basic problem. Okay. So in the next video, we'll discuss about bit complicated. Okay. Procedure will be same. Fine. Like the D value will be 0 to 9 exactly. 0 to 9 D value will be. Okay. We'll discuss that. Thank you, students.